Hello students, I welcome you all in the quick solutions of All India AIATS Test Series Medical 2019. And I am here with the test number 3, code A and B, and we will be dealing with chemistry section. Let's begin with the very first question of the chemistry section, that is question number 46. Which of the following aromatic compounds undergoes nucleophilic substitution reaction most easily? It means you have certain aromatic compounds in which you have to find out the compound which undergoes nucleophilic substitution reaction most easily. Generally, we know that in case of haloarenes, nucleophilic substitution reaction is not so easy. But if some electron withdrawing group is present at ortho or para position, will increase its reactivity towards nucleophilic substitution. So what we have to find out in this question, we have to just check the substituents present here. So if we talk about this group, this is methyl group present at para position, but this is electron releasing group, not the electron withdrawing group. So this is electron releasing group. Further, we have this nitro group, and definitely it is electron withdrawing group. And if it is electron withdrawing group, it can increase its reactivity towards nucleophilic substitution reaction, and even it is present at the para position also. So definitely it will increase the reactivity towards nucleophilic substitution reaction. But let's check further option also. This next group is present at the para position to this chloro, but this is electron releasing again. And if we talk about this methoxy group once again, in this case, let's see how this electron withdrawing group increases the reactivity towards nucleophilic substitution. So we have this compound here. This is para-nitro chlorobenzene. You know that. Now, on this, if some nucleophile, suppose this is the nucleophile that is attacking, and this is the slow step of the reaction, it's attack over here, and further it gets changed into definitely it will be attached here. Now this would be formed, and we know that it can easily participate in resonance. So the resonating structures, those you can draw here, would be this is the negative charge. Yeah. Now further, one more resonating structure can be formed here. This type of structure. In this case, this negative charge would be here. Further, nitro group present at the para position also increases the resonating structure. This would be. And further, we can also draw here the hybrid for this species. This would be, and further, in the fast step, there is the formation of the product. This would be the product here. Along with that, this nucleophile is removed. It means in this compound, para-nitrochlorobenzene, this nitro group present at the para position has increased the reactivity towards nucleophilic substitution reaction, and that's why we can say the correct answer for this question is definitely option 2. So just mark here answer, that's option 2. Now after this, it's a turn for the next question. Question number 47, the compound which will react with aqueous KOH is. This is the reaction in which we just want to identify the another reactant which is reacting with KOH to form the product. In this case, if you're talking about this reaction, the compound which has more acidity as compared to water will definitely react with this aqueous KOH to form certain product, that would be salt and water. So here, if you look at the given compound, the first option is here, this is an alcohol. Further, second option also contain alcohol, and third option is also an example of alcohol. We know that alcohols are less acidic as compared to water. But if we talk about phenol, this phenol is more acidic as compared to water, and on that basis we can say it is more acidic as compared to water, and due to this nature it will react with aqueous KOH to form product, and that's why I'll choose this fourth option as the correct answer. Now after this, it's a turn for next question. Question number 48. Which among the following compounds is most easily dehydrated in acidic medium? So we have different options, different compounds are given here, and we just have to check which of them will dehydrated in acidic medium most easily. Let's check what will happen on dehydration. So first option we have here, this group is present at the second position. Now acidic proton is attacking on this compound to form the carbocation. So I'm just forming here the carbocation. This is the carbocation. Further, removal of this proton to form alkene, and it will result in the formation of this alkene. Now, further, the next compound that's given in option 2, OH is at the third position. Attack of this acidic proton, formation of intermediate, that's carbocation, and here is the removal of this proton to form alkene here. After this, it's a turn for third option, that is this attack of acidic proton, formation of carbocation, and further formation of alkene also. So here is the formation of alkene. After this, we are left with the fourth compound. Let's show this reaction only here. In this case, first the attack of this H plus ion, and it will result in the formation of carbocation, and that would be this type of carbocation. Further, removal of this proton to form alkene, and that alkene is here.
The ease of dehydration is decided by the stability of carbonium ion and the product formed. Now, if you look at the given carbocations, in this case, all the obtained carbocations are secondary carbocations. So, we have to consider the product obtained in each of these cases. If you consider the product obtained in the case of second option, that product is stabilized due to resonance, and that is why the compound which is most easily dehydrated in acidic medium is given in the option 2.
And now after this, we have the next question also. Question number 49. Consider the following sequence of reactions. We have a reaction sequence that's given, and further product C we have to identify. Let's check the reaction given here. Now here is the reagent, that is KCN. There is the nucleophilic substitution reaction to form the product nitrile. Further, it is heated in the presence of acidic medium, and then it will form CH2COOH. This carboxylic acid would be formed. Further, what you are doing? Esterification, C2H5OH, that's alcohol you are adding in the acidic medium, and then ester would be formed. So the ester that would be formed here is CH2COOC2H5. So this is the product that would be formed, and it is an ester. And now you can easily identify this is A, This is B and this is the compound C. Let's mark here the correct answer. That's given in option 2. Now, after this, let's take next question. Question number 50. Total number of optically active isomers of tartaric acid is. We have different options given here, and we should know that tartaric acid is optically active compound. To identify the optically active isomers of tartaric acid, we have to draw its Fisher projections. So let's draw its Fisher projections. Here would be this carboxylic acid group. This is the first isomer. Further, the second one. In the similar manner, I can simply draw it. This is the second one, and we can easily identify the chiral centers here. We have 2 chiral centers this way, and further let's draw it's the next mesoform also, and that is the mesoform of tartaric acid. If you look at this structure, you will identify that this mesoform has the plane of symmetry, and if it has plane of symmetry, then definitely it is optically inactive. So this form is optically inactive. What about these two? This is optically active. This is also optically active. And on that basis, we can say that total number of optically active isomers of tartaric acid is 2. That's given in option 3. And that's why the answer is option 3. Now, after this,